Hello everyone, welcome to my channel. In this video, I am going to provide you the solution for our NPTEL course, that is C Programming and Assembly Language, and this is the solution for week 1 assignment. So in this video, I will provide you the solution for question number 5, 6, 7 and 8. So this is our question number 5 and 6 is given, and for the 5 and 6 question, the text will be given here. There are total 4 bytes are stored in that extra segment. So these are the elements that are stored in that extra segment. And these are the code snippet is given, and based on this code given, we have to identify what is the value of EDI after execution and what is the value of ECX after execution. That we have to find out. So we will execute all this statement and we will try to find out what is the value of EDI and ECX. So in the given example, the element 91 is stored at starting address location. And whenever we have to search the element, that time this will be incremented by bottom to top location. Suppose consider that these are the elements that are stored in that stack. So I'm writing here 91, 44, then 13 and 28. And the starting address is equal to 91 is given as per our example. And we have to search the element that is 28. So here that is written, you have to find out the element that is address byte 28. And this element will be scanned from this bottom to top location. Because our starting address is located at the number which is stored 91. So the first statement of our program is move AL, 28. So the value of our AL is equal to 28. Now the next statement is move EDI, starting address. So we are storing here EDI is equal to whatever the starting address location contents are there, that will be provided into the 91 into our EDI register, that is extended destination index register. Now move ECX, 8. So 8 is the counter value that we are providing it to the ECX register. The next statement is CLD, that is called as a clear direction flag. So here the direction flag will be set to 0. The next important statement is repeat not equal scan SB. That is called as repeat if not equal, then it will scan the string byte by byte. So whenever we are executing this statement, that time your destination index will be incremented by 1 and your counter will be decremented by 1. So each iteration that will happen. So in the first iteration, suppose these are the element that is 91, then 44, 13 and 28. And our starting address location is currently that is 91. So in the first iteration, the starting address location, that is the value of our EDI, is equal to 91. That time our counter value is equal to 8. Now whenever we are scanning the string, that is scan the string byte by byte, that will be done. That time we are repeatedly execute this statement till our whole string will not be scanned. So here the value of our 0 flag is not equal to 1. Till that we are executing this statement. So here the scanning of string, once we are scanning this 91, this counter will be decremented by 1 and it will become 7. In the second iteration, our counter is 7. Now what we will do? We have to again check that our counter is also not equal to 0. Till our counter is not equal to 0, we will repeat the string and we will scan the string byte by byte. So here we are again scanning the string. So that time the value of our EDI will be updated and it will be point to the location that is 44. And the contents are currently 44. Again we are decrementing the counter value by 1 and it will become 6. In the third iteration, the value of our ECX is previously that is 6 and our 6 is not equal to 0. Then again we are scanning the string. So here the next string will be scanned and it will be goes to the element 13. So our now EDI contains the value that is 13. And whenever we are scanning the string byte by byte, our destination index will be incremented by 1 and our counter will be decremented by 1, that is 5. Now in the fourth iteration, we have to check what is our counter value. So our counter value is equal to 5 and 5 is not equal to 0. So here I am writing this value of our EDI that will be scanned by our element and we are locating from 13 to our 28. So our value of EDI is equal to 28 and again we are decrementing this counter by 1, that is 5 minus 1 and we got the value that is 4. So here we have searched all these atoms and our starting location will be 91 and once we are scanning all these elements we will reach to the 28. And as per our question, what we have to find out? We have to find out the byte 28 from this array. And we got this element and now what we have to find out? The answer for this question. So true or false question can be asked and here EDI stores the correct address of the element 28 after execution. So once we are executing all this statement, we got the value 28 in our starting address. So now this question answer for this question is true. Now we have to provide the value of ECX. So once we have executed all this statement, our counter value we got that is 4. So the answer for the question number 6 is 4. So for question number 7, we have to refer this data that is given the values of extra segment, that is extra code segment, extra data segment, extra stack segment, extra segment, extended extra segment and this extended AX register, extended BP register, the values are given. And there are two arrays are given and the address of the array 1 is given. The data value that are stored in that array 1 is given, address of array 2 is given and the data that is stored in that array 2 is given. So in that data array 1, these are the 5 elements are stored and in the data in the array 2, all the elements are 0. So we have to find out after this execution, what are the contents of this data array 2 and what are the contents of this data array 1 after execution of this statement. So now let's start with our answer. So here, what is the first statement? That is clear direction flag. So here, the value of our direction flag become 0. Now the next statement is move ESI, that is extended source index is equal to our value is 0x102. So what is the value of our ESI and what is the value of our EDI? That I am writing first, that is 0x202. That is the value in that ESI and EDI instruction. So whenever we are executing this move instruction, the values will be copied into ESI and EDI register. Now we have to check where the value is stored in that array 1 and array 2. So this array 1 can be considered as a source index and this array 2 will be pointing to the destination index. And we have to check what is the memory location will be stored after execution of these two statements. So in that ESI, the value is stored that is 0 into X102. So this value will be pointed by our ESI. And after executing this statement, we will point to this memory location, that is 202. And this will be pointed by our EDI. Now, what is the next one? What we have to find out? We have to find out this statement of that result of that operation and what are the contents of this array 1 and array 2. So here, what is the counter value? We are writing move ECX, 2. Then our counter value become 2. So the next statement is repeat move SB. So this is the repeat statement, and whenever we are repeating, that time we will repeat till our string will be byte by byte copied into our destination string. And this will be done with the help of this counter register if our counter is not equal to 0 till we are moving the string byte by byte from our source index to our destination index. So this is the operation that will be performed by the statement. Now we will start the execution. So whenever you are executing, you have to remember this operation. So the first one, where we are at the location that is on ESI is equal to 0 into 16102. The element is stored, that is 17. And here we are writing this element, we are pointing to that element 17. And this 17 will be copied into our EDI location. So previously in the array, what are the locations will be stored? So previously in the array, all the elements are 0, 0, 0 in array 2. So how the elements will be updated? We are writing here the array 1 and this is our array 2. So in that array 1, the elements are 11, 14, 17, 19 and 23. And here all the elements are 0, 0 and 0, 0. So here we are pointing to that 17 content, and this is the memory location that will be pointed by our ESI. So whenever we are transferring the data to the location, that time we are pointing to this 202 location, and this is our 202 location. And whenever this operation will be performed, first of all we will check the value of our counter. So now currently the counter is equal to 2 and 2 is not equal to 0, then we are repeating this string byte by byte. We are moving the string byte by byte from our ESI location to our EDI location. So now my contents of our ESI, that is extended source index string, will be 17, and that we are copying into the EDI location. So what is the EDI location? That is 0x202. So here I am copying the value, that is 17. Now once it is executed, then our EDI value will be incremented by 1 as well as our ESI will be incremented by 1. So it will be incremented by 1 and our EDI will be also incremented by 1. So what is the location in that ESI and EDI? That is 0x102, and once we are incrementing, it will become 0x103 and this will be 0x203. Now we are pointing to the next element. So here we are pointing to the 19. And again we are performing this statement, that is repeat move SB. So that time also we have to check this counter value, and our counter is equal to now decremented once we are doing the first iteration. So here our counter is decremented and it will become 1. So here we are taking the counter value is equal to 1 and 1 is not equal to 0. The condition is true. Here is also condition true, so that we have copied the contents of 17 into our EDI location. So now the contents of our EDI will be whatever the value we are pointing from this source index register. And from the source index register, we are pointing to the element that is 19. So 19 will be copied into our destination index. So here I am writing 19 will be copied into our destination index. So it will be copied into the location that is 0x203. Now whenever we are copying the value, that time again our counter will be decremented by 1. So previously it is 1. So 1 minus 1 is equal to, now it is 0. Again we will go to the third iteration. But what will happen whenever we are going to the third iteration? We have to again execute this statement, that is repeat, then move SP. But here what we have to check, if our counter is not equal to 0. And here the counter is 0. So 0 not equal to 0, this condition will be false. Then we will not execute this statement and we are not copying the contents of our source index into our destination index. So this statement will not be happen in that particular iteration. So we are going to that our array data contents and we will check what will be the final values of our contents of our array location. So the final values of our array locations are, that is array 1 is equal to 11, 14, 17, 19, 23. That is same as per the given example, but our array 2 will be updated here, that is 0, 0, 17, 19 and 0. So we have to find out the answer where it is. So the option is C and we got here this data array 2 in that instruction. So as per this manner, we have to execute all this instruction and we have to find out the elements of our array 1 as well as elements of our array 2. Now we will see the question number 8 and question number 9. So the address for the to be pointed in the given by the value stored at EAX location, and that is the constant value 2. Whenever we are executing the single instruction, the address will be pointed by the store in the data segment. And we have to take this address from our previous example because that is mentioned the address of the segment is same as the question above. So question number 7 we have to check, and here the data segment address is given, that is 0x1600. So I'm taking this address here, that is called as a segment address, is equal to 0x1600. Now we have to identify what is the type of addressing is done with the help of this above question. So here the offset address will be given. So I'm writing here the answer for this question is indirect with offset address. Now we will see answer for the question number 9. So in the above question, the value of EAX is given to be 0x38. So now we have to find out the address, and this address can be calculated as the EAX value plus 2, because here that is mentioned in the question, the value of our EAX will be added with our constant 2. So in the given question, the value of EAX is given, that is 0x38. That is taken from here. And we have to add here 2. So whenever we are adding 38 plus 2, so in case of hexadecimal, 3 will be considered as 0011 and 8 will be 1000. So 2 will be writing here 0000, 0010, and when you are performing the addition, then you will get the result, that is 0011, 1010. So this will be written as 30 plus 8 equal to 40, but we will write it here as 3 and this one is 8. So I'm writing the answer, that is 0x38. That is the address we got. But here we have to find out the complete address that will be accessed by whenever we are adding this value. So how we are calculating the address? The previous address of our data segment that we have to calculate. So I'm calculating here the effective address is equal to, what is the base address in the previous question? That is 01600, and we are appending here 0 for calculating our physical address, plus what is the value of our address that we got, that is 0x3a. So once you are adding all this element, you will get here 0x163 and a. We can append here 0, so you will get the solution for this question. So answer for this question is 0x163a. So in this way, you can find out the answer for the question number 8 and question number 9.